I'm starting up the stream. Should be going soon. Looks like the stream is going. Hi everyone, I'm Deque, and today we're going to start to finish our custom Deque module class thing. I think the only things that we're missing right now are a del item method, so we can use del, the keyword del on an element of the deck, and get item, set item, and del item for slices. And I don't know if my voice is going to be a little more scratchy today. I'm developing a cold, so sorry about that, but I wanted to do Python stuff. So here we are. Okay. We need del item. We're going to start with this. I will be refactoring these things because copy paste is generally not okay. Okay. Instead of just saying the current element that we're interested in gets a new value or is returned or whatever, we have to delete it. So, to delete it means we have to get the nodes next to it and make them point to each other. And that means so that's good. That's good. That's a good start. We're gonna need that. If we're going forward, that means the node before points to the current one with next. Otherwise, it would point to it with prior. So, if we're going forward, if there is a node before, then before.next should point to after. Otherwise, if there's nothing before, then we've removed it, so there's nothing in the current. So that would mean after is the first one. If we have a node after, then let's see. Then after dot prior needs to point to the node before, and if we don't have anything after, it means the node before is now the last thing. Equals okay. If we're going backwards, this is all going to be very similar. If before prior and last and next and first. There. Beautiful. Okay. Let's create a kind of generic thing, because all this stuff, this is very similar. These are the same. The only difference between the get and the set are that we either return it, literally just that line, or we set a new element. And we have something similar here, where the difference is this block. So, we would have each of these being different functions, and then they would send the information we need to this other function, which we will call what? Get set del? I don't know. And it's going to have an underscore, because that's not supposed to be user accessible. It is, but this is to inform people that you can ignore that. You don't need that. It's a convention that means it's for internal use. So, let's see. So what will it need? It will need either the index, which is an index, an integer or a slice, and it might have an element. And it will need the choice. So I, element and choice. I think I'm missing something here, but that's okay. All right. Let's start with some copy-paste. If this, we do that. And I think we will return stuff. If choice is set, let's start with get in order. If choice is get, then we will return the element, which is current.element. Current element. If the choice is set, we will return actually, can we just return all three? I think we can just make it do that. Let's start by replacing our stuff with something like this. We're going to have it call that. We're going to have I element, which is none, and choice is going to be get. Should we return it here, or should we just do the operation? Let's just do the operation, which is let's actually do return that. Okay. Not the whole thing, just some of it. Okay. Not that far. If the choice is set, then current.element equals element. I could have an else here, because it's not going to be called with anything other than get, set, or delete, but... And let's do else return, I don't know, fail. Raise, what kind of error? Type error, value error, index error, value error, because it's the wrong value of choice. Choice must be, and let's make this a double quote, so I can say must be get, set, or del. Great. I could probably do that with the remove or replace also, but I don't know. It doesn't really matter. So, if it's delete, then we have all of this stuff. Great. Before, else, after, else, great, 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 good. So this can just do, return that, or self dot get, set, delete with I and the element and set and then nothing else. This stuff is gonna have something that happens in here also. Let's just put it in there right now. If it's an integer, if it's an either, return an error. If it's an integer and it's wrong, we say so. And tell people what it should be and what it was. I think that's a useful error message. Now if it's a slice, then we have to check whether it's a slice, etc. and so forth. Get, set, and del should be same thing. I element instead is none, it doesn't matter, and del. So this right now should work. I think. So we have a very short get, set, or delete, and then it just sends it to here. It says if we get, then we do this, set, we do that. And then there's a whole thing with slicing. It's complicated. The only thing that supports slice assignment is lists, because they are a sequence and they are mutable. Other things that support slicing are tuples, strings, anything else? Might be something else, I don't know. The standard collections.deque does not. But you can only access slices of strings and tuples because those are immutable, you can't change them. So when you have a list, there are some rules. You can only modify the length of the list by a slice assignment if the stride or step of the slice is 1. -1 might work, I'm not sure actually. Would that just reverse it? Let's find out. We have our list, okay. 1 equals ABC. I don't know. That doesn't work either. So yeah, it does this. It says your sequence is this large, and extended slice means you gave an explicit step instead of leaving it empty or none. So it could have done this, and then it works fine. And then our list is just ABC. The pitfall to this, you can also do this with generators. We can say L equals list A, B, C, D, E, F, G, H, I, J. That's enough. And then we can do L this, whatever, equals iter. Actually, let's do first I equals iter. We're making an iterator out of a range object. L, let's say only the first item changes, equals I. We can do that. So instead of item 0 to 1, not including the 1, meaning the A from our list, we now have 0, 1, 2, 3, and that's what we've got. But look at I now, it is empty. So let's do that again, make another I, and L, say every other is I. Oh, that doesn't work, because we have a sequence of size 4 and the extended slice has a size of 7. Let's try it again. And now it has a size of 0. Because it went through it, it exhausted the whole thing, and checked how many there were. And threw everything away. So that is a pretty large thing to look out for. If you are using a generator for something that you think you will only need once, maybe because it's very large or gets something from a server, so it's a lot of data and it's an expensive operation in some context, whether CPU or RAM or bandwidth, I don't know. So you want to replace part of your list with it, and you have some sort of bug or whatever, and it or you don't know about this, maybe, and then you try to assign to a slice of the wrong size, and and all your data are gone, because it exhausts it, checks how many there are, and then says this is the wrong quantity, and then throws them away. And if you had a lazy generator, you would have to get all those things again. So it would do all this expensive operation, high bandwidth, whatever, and then it would say, oh look, all the stuff I went to all this effort of getting is wrong, so goodbye. So that's then you would want to save it into something first if you think it might fail for some reason, if you have this in a try except or whatever. So I think ours will not do this, because it's only the list type that behaves like that. I think mine is going to have ours is going to be a little more permissive. So if it's an int, okay, let's do some slice error checking. If it's a slice, we need to make sure that it has a correct start, stop, and step, which should be none or integers. If you want, you can you can make a slice object with potato and a lambda function and no step. And that's fine. You have a slice that starts from potato and ends at an anonymous function. And I don't know when that would be useful, but you can do it. You can send any object you want to slice. But the only ones that make sense for this are integers. That's what we're going to do. So, if not all, one moment. So if not all, we want to check that each of start, stop, and step have are either none or are an integer. Is instance part int? That's how it works. Yeah. Int or part is none. Actually, can I check? You can technically, if you want, you can have a tuple of types that you're checking. Int, string, and true, because one of them is proper. None is an object, not a type. And I think it's none type. Type of none is none type. Maybe if I put a capital letter in there. No, it's not a thing. You have to check if it is none. You can't check the type. So that would be faster to write, but it won't let you. So we check if it's an int or none for part in I dot start, I dot stop, I dot step. So if that's not all happy, then we say type error of this. Integers or none or have an index method. I don't know what that means. So I'm not going to say it's fine if you do this thing, because maybe someone's going to have that, and I don't know if it's handled automatically or explicitly. Must be integers or none. Empty. Okay. That's a good start. Let's do some testing. Blah blah blah. Delete 0 and print D. Let's actually print D first. Let's get this and that up there. So everything good. We removed 0. That works. How about -1? Removed the last item. So that's good. That works. say it's a slice, and then it won't do anything as far as I recall. It doesn't do anything, because we haven't told it to do anything. One movie that should be required watching for any programmer or developer or person who works with machines should be Terminator 2, Judgment Day. Because there's a part in this movie where John Connor is talking to the Terminator, and if you haven't seen it, John Connor is like a how old is he? 14, 15-ish year old kid. And the Terminator is a robot from the future. It makes sense in context, and it's not a comedy. But this kid is talking to a robot from the future, and this robot from the future has been sent to save him. And since it's from the future, sent by him, he programmed it to do what he tells it to do, and his past self is still him. Him in the future sent this robot back. So when he gives this robot a command, it's supposed to do it. And he learns this when he's arguing with the Terminator, and the Terminator is kind of holding him up, just kind of not really doing anything, but annoying John. And then John says to let me go. And immediately the Terminator lets him go, and then John falls on the ground. And John is very upset. Why did you do that? And the answer is very important for any programmer. And the answer is, because you told me to. That's computers. If you tell it to do something crazy, delete your hard drive, it will do it because you told it to. If where's my stuff? If you said check if it's an instance, and then check if all the indices are good, and then stop doing anything, it will not do anything. And that's that. Okay. That is a good movie. I recommend you watch or rewatch it. Slice. Okay. By this point, we have determined that our slice is good. Hopefully. In that it has integers or none. Let's check if the integers are also good, meaning they have to be... Do they have to be in range? They actually do not. So, because slicing is pretty permissive, S is an empty string. S0, there is no zeroth item. It's empty. Doesn't have anything. You can also say S4 to 12. It doesn't have anything. So it just goes as far as it can. This can be good or bad, depending on what you expect it to do. Let's see. First thing I think we'll do is we'll check the step, first of all, because that's going to determine whether our start and stop are actually the stop and start. Because if you have show you what I'm doing. Hello. I'm gonna give it an explicit index of step of 1 goes forward. You say -1 goes backwards. But this time it starts at the end and ends at the beginning. That's what happens when you have a negative index. It goes the other way. So, what does that mean? It means we have to check. Step equals I dot start, I dot stop, I dot step. Good. Step should actually be step or 1. Because if it's none, then we will want to replace it with 1. That's the default. Note that this will also change 0 to 1. In actual slicing, if you give it a step of 0, it will explode. It'll be an error. And that error is, I think it's a value error. If I can type the closing bracket. Value error. Slice step cannot be 0. Let's just do that. Step is 0. Why didn't it do the thing? Could have sworn. Value error. Not that. Slice step cannot be 0. Great. Why would someone do that? Why would someone pass 0? It doesn't make sense to pass 0, but you can pass it none, and then it'll just imply that it's 1. Is this a choice that someone would make? They'd probably want to do that beforehand. If they had this error behavior, and they want to check whether a slice is okay or not, saying if it's like a number, a non-zero number, or 0, then they could like try and then accept a value error and then do stuff. But if I took out this part, then they would need to just say if step, or if step not equal 0, or something. Have an if statement in there, or a try except. We're gonna eliminate that, because I already know it's gonna be different. I don't think, I specifically do not want to emulate the default behavior, because the default behavior is exhausting generators and iterators, and then if it's not suitable, throwing them away. I don't like that at all. Okay, we change that to step or 1. If step is less than 1, meaning if it's, we could have said less than 0 also, so that would be negative. Start stop equals stop start. We flip it around. Actually, let's do start and stop first. Start equals we just want to say we We want the index. We want the normalized index. Right? I think. That just gets the max. What does that thing do anyway? Norm index. Min max if it's less than 0. This allows us to get any number. Let's say we have possible indices. Allows us to get any number and puts it back to where it should be and makes negative numbers positive. Norm index. I will reuse this. Yay. Norm index with I and the quantity. Where did it go? Here we are. Self dot norm index. I self dot not I dot start. No, just start. Thank you. Start self dot quantity. Stop. We'll self dot norm index. Stop and self dot quantity. Cool. Looks good. What happens if we have a slice where the end is before the start? It's just empty. Okay. That's more behavior of stuff. Oh, these might be none. Okay. So we'll do this afterward, because we have to check if it's none. Say we're starting at the beginning and going to halfway, but if we are going backwards, we would have halfway and the beginning, and then this is going to be a lot of flipping things around over and over again. Okay. Should we first check for none? The start should be is that automatically 0? I think that is always 0. But it might not be included if we also end at 0. Slice that isn't in there. This might take a little more time than I had planned, because we're already at 40 minutes, so it might be good to start here, stop here. Perhaps I will think about this more offline. And then it doesn't do anything. It's incomplete. And then after that, we will return and do more stuff. We'll have to figure out that logic, whether to replace none with something before we check the direction or after, and swapping it around. So, and 40 minutes is already pretty long. So I think we will call it here. This works fine. The things we added are working, and I think that now we have append. We have append left. We have clear, copy, and count. We have extend and extend left. We have index. We have insert. We have pop and pop left. We have remove. We have somewhere, we have reverse. And this one is O of 1 instead of the standard library's O of n. Ha ha ha. We have rotate. And we have maxlen. Should we check whether that's an integer? Can I pass? I probably can. I don't need that. Maxlen equals a string. An integer is required. If not is instance, and how about a negative number? Must be not negative. Is instance maxlen int and or if it's not an integer or maxlen less than 0. It can be none though. If maxlen is not none and not an integer and negative, no, maxlen, if it isn't none, because none means there's no limit, and it's not an integer or it's negative, let's check these one at a time because they're different error messages. If it's not an integer, raise something. If it's less than 0, raise type error. An integer is required. Value error. Maxlen must be non-negative. Okay. So at this point, because none is okay, that means there's no limit. But if it's not none, if it's not an integer, we say it's an integer. At this point, we have confirmed that it is an integer, but if it's less than 0, then it must be non-negative. Okay, and then we check it later with if it's not none, meaning there is some kind of limit. And blah, blah, blah. Okay. Let's save that. Back to here, open this, test it and see what happens. What did I do? Oh, because it's none. Yeah, I can't do that. We had none somewhere for the integer, because this is an integer. I mean, this is none by default. So something there is very unhappy. If it's a slice, norm index. Oh, for start and stop, yeah. If start is not none, what just happened? Oh, okay. No, I want this one. If stop is not none, okay. Good. Let's give it a maxlen that isn't happy. There should be nothing. Deque index outer range, right? Because it's yeah. There's nothing in there. That's fine. That's correct. Equals a string. An integer is required. -1 must be non-negative. Good. Cool. Let's change this to like 4 or something and then print both, just to see that that part works. 0, 1, 2, 3, 4. The E is gone. Now it's just F. Great. Cool beans. So today we refactored the get and set, and we added a delete in the same way, very short, and moved everything to get, set, del. And we started on slicing, but it doesn't work yet, because I don't want to do that now. And we fixed maxlen. So basically, we added del item for ints, refactored, and fixed maxlen error checking. So there we go. These will need an else. If it's not none, then we have this. Else, meaning if it's none, we do something. It would probably be easier to have if start is none. Pass, else whatever. If stop is none. Pass, else whatever. Just take out all the extra negatives you can. If it's none, do this. Otherwise, do that. Because by now we know it's a number. And maybe we won't want an else at all. We'll just pass it an index. Pass it. We'll just assign a new index that's appropriate based on the step, etc. Not today. Alright. So let's keep checking other stuff. Maxlen, I got that. Deque support iteration, yes. Pickling, yes. Len, yes. Reversed, yes. Copy.copy, copy.deep copy. Membership testing with the in, that's contained, we have that. that's, you know, that's that part. So support iteration, support len. Pickling it already does. I don't have to do anything special. Reversed, we also have that. Copy and deep copy work already. Contains for in, subscript references, meaning get item, and of course set item and del item. Index access is O of 1 at both ends, but close to O of n in the middle. Yes. Starting 3.5. And we have that mul and imul. I don't know if there's anything else. And comparison. They don't mention, but you can compare various decks. So at this point, we can safely say that it matches all the functionality in the standard collections.deck, except for maybe a few small quirks that I haven't gotten to yet, like maxlen. I had to error check that. So maybe there's other little minor things, but as far as functionality, it's the same. Overall, the standard one is faster. Just use that. But if you're planning on reversing it a lot, then maybe use this one, because here reverse is O of 1, even for very large ones. Probably still not enough reason to ever use it, but that's okay. It's still cool that it's O of 1 for reversing. So, and it has a few extra things that the standard collections.deck does not have, like instead of just removing the first item it finds, you can remove any number of items from either end. I mean, starting from either end, and you can also, it has a replace, which instead of removing a node entirely, will just replace its value, and you can replace any number of things starting at either end. And perhaps next time it will have slicing as well. So that's cool. Alright. That is the stream for today. You can see other parts of this project archived on my channel. And you can find the code at the GitHub repository linked in the description. And remember to like, comment, subscribe. I will be doing more of this in the next few days at some point. And that'll be cool to be finished and have something neat. So, thanks for watching, and I will see you next time. Have a good one.